All right, so here are the sinusoidal functions that are being transformed. So we said that if you had a parabola like such, and you transform that, it would be y equals a times x minus h squared plus k, where the k moves it up and down, and the h moves it left and right, and the a stretches it. Well, the same thing for the sine function is we're going to have those stretches as well. And so if you want to move a sine function up 3 units, it would be y equals sine of x plus 3. And that would move the sine function up 3 units. Let me show you a graph. So here is the graph of a normal sine function. It looks like this. I'm going to make it red. And we're going to zoom in here a little bit, make sure we have a whole period in here. So I hope everyone sees how it starts at 0. Let me zoom in maybe just a little bit more. It starts at about 0 and at about pi, which is around here, right? Pi is there, and 2 pi is over here. That's the whole cycle of the sine function. And so if we're going to move this up, we have y equals sine of x. And this time now it's plus 3. And let's zoom out a little bit and move up. Oh my God, look. It's the same function, but moved up by 3 units. And I'm going to make sure that this one is green, because that matches my other graph from the other one. So that's how we move a function up and down. What about number 2? Number 2 asks about reflecting it. How can we reflect the sine function across the x-axis? Well, all we have to do, how do you reflect a parabola? Well, if the parabola is pointing up, that's y equals x squared. Pointing down will be y equals negative x squared. So we have to change the a value to be negative. So all we have to do is do y equals negative sine of x. And I want this color to be blue. And so that would be the mirrored form of the sine function, the one reflected across the x-axis. And then the next one asks, let me make sure I get this right. The next one asks about, I believe it's adding 2. Yes, 2 to the right. So if we're going to go 2 to the right, in Desmos, that's really easy. You just do y equals sine of x. Now, we got to be real careful now. Remember how we move 2 units in a parabola? It's that h value. So it's within the parentheses. So it goes like this. But I forgot the parentheses here. And I'm going to make this one black. And so notice it's still the same curve, but it's moved 2 units to the right. So instead of starting at 0, 0, it starts at 2, 0. But everything else is the same. So that's shifting the sine function to the right by 2 units. And then finally, we're going to do a stretch. How can we stretch the sine function? Well, how about we stretch it by, I don't know, 3? So let's stretch this by a factor of 3. You would just put, just like in the parabola, if you stretch it, that you're going to make the a value greater. You're going to make the a value 3. And so all you got to do is put a 3 in front. And what this will do is it will make this thing, it will stretch it vertically by a factor of 3. So you still have the same period. It still takes 2 pi to go from 0, 0 to 2 pi comma 0, right? From this 0, 0 here to 2 pi. Just like the red line, it takes 2 pi, but the amplitude is different. And you can remember it's called amplitude because it's the a value. And just think of like sine waves, like if someone's really loud, then that a value is really high. And when they're really quiet, then the A value is really kind of low, and it's just like a small A value. So that's how I like to remember. The amplitude is the stretch. It stretches the sine function and it moves it up really nice. Okay, so those are those functions. There's only one more thing to talk about, and that is how to change the horizontal stretch, the periodicity. So what if you wanted to compress it and have it go through its cycle faster? It's going around the circle faster and faster. That's actually also pretty easy. We don't really have anything like this for the parabola, but here in sinusoidal land, that would be sine of 2x. And I'm going to make this one orange. And so if you look at sine of 2x, if we can just ignore the other ones, let's look at this one and the red one. What the red one takes 2 pi to do, by the time we get to 2 pi comma 0, the orange has already been through 2 whole cycles, whereas the red one just finished 1 cycle. So it's not changing the amplitude, right? It's not changing the amplitude like the purple one. The amplitude is still the same, but it's just going through its cycle faster. And so that's indicated by the coefficients on the variable inside the sine function. So some people will put parentheses around this, like this, just to make sure they understand it's inside that sine function, in the input. And that's what's going to make it cycle through faster, is going to make the period shorter, because it only takes pi now to get through the whole cycle instead of 2 whole pi. So those are all the things we have to know for the next couple days. So hope you understand that, and good luck to you all.